Hello and welcome, friends. So today we are going to talk about one of the topic that is very favorite for CAT and other MBA entrance exams like NMAT, SNAP, IFT. If you see typically your CAT paper or the CAT syllabus, there are a significant amount of weightage that is given to arithmetic. So if you see your CAT paper, there are around 60% questions in CAT that comes from arithmetic. And within arithmetic, we'll start with time and work basics because time and work is one of the most doable area if you understand the concepts clearly. There are not much formula to remember as such, but if you understand the basic concepts and solve few problems, you will be able to solve most of the time and work problems. So it's a very much doable area to start with. And typically we have seen in past years CAT has got around 2 to 3 questions, or 2 questions, not three, maximum 2 questions you will get from time and work. But if it comes to NMAT, SNAP, IFT kind of exam, you will get something around 3 questions from time and work specifically. Now, why time and work is such an important area? Because if you see, this is one area you have done it in the past also in your schools, but where we'll focus now and why it is more important in CAT is because of the application. So there are hardly any formula you will remember, but we will do some of the scenarios and try to solve few problems on time and work. So what is the agenda for today's session is basically we'll talk about the fundamentals of time and work, and once the fundamentals are done, in the subsequent session we will cover the level 1 problems or the practice problems for time and work, and in the third session of time and work we will do a level 2 or the advanced level problems of time and work. So that's how I thought we will have this session. Once on the fundamentals, which is happening right now, then the next session will be on the level 1 problems of time and work, and the third session will be on advanced level problems of time and work. So that's how we will plan it out. Without further delay, I think let's get started. So what we'll do in time and work basics, we will cover this into three main area. First area being the methods. I will talk about time and work methods. Then we will see different scenarios. What I mean by scenarios is the different type of problems that can come in time and work, and certain but typical scenarios of problems from time and work. And then finally we do some of the applications. Applications as in apart from typical time and work, we will see some of the applications of time and work. We'll go there and we'll talk about it. So with that, let's get started. So if you understand from the title of the topic, there are two elements. One is time and another element is work. So there will, for every problem there will be certain entity around time that will be given to you, and then there will be certain entity description around work that will be given to you. So if we see carefully, let's say a given problem, let's say my name is Orko, and then I have a friend whose name is Sham. So both of us started doing a work. What can be the work? So I'm into consulting, so let's say I'm making a PowerPoint presentation in 2 days. So in 2 days make one PPT or presentation. For Sham is more efficient than me, and Sham can do it in 1 day only. Sham make one PPT in 1 day. So you see, when I make the statement that Orko makes one PowerPoint presentation in 2 days, so there is a time element which is 2 days, and there is a work element which is one PowerPoint presentation. Normally we have these two elements, and normally if something is not quantified, typically the total work in total considered to be 1 unit or as a whole unit. So it can be 1 PPT or it can be 10 PPT also, but it together it considered as a one whole unit of a work. So that's how the basics of time and work works. So now there are two type of ways to solve a problem, but where is the problem? Good question. So we'll see. So it talks about Orko take 2 days to make a PPT and Sham take 1 day to make a PPT. The typical question is, okay, what if Orko and Sham start working together? How much time they are going to take? So this is a very basic time and work problem. So they you have given individually, you know how much time each of the person takes, but what if they work together and how much time they are going to take? So if it is like that, so there are two methods to do it. First we'll start with the unitary method, which most of us has done till then. So say Orko, I'm writing as A. Orko take 2 days to make one PPT. So Orko in 1 day can do half of the PPT. Okay. Similarly for Sham take 1 day to make one PPT. So if I say Orko plus Sham in 1 day can make 1 plus half, which is 3/2 PPT. So Orko plus Sham makes 3/2 PowerPoint in 1 day. So they make one PowerPoint in 2/3 days. So that's the time that we are going to take. So that's how the unitary method typically works. So when you say Orko takes 2 days to make a PPT and Sham takes 1 day to make a PPT, obviously when they work together they will take less. So also one important thing is to remember that together time is lesser than the person taking least time. So what I mean by that is together we are taking 2/3 of the day, so that's less than 1 day. Here between me and Sham, so this should be Sham, so me and Sham, Sham takes, sorry, this is Orko only, it's my bad. Yeah, so me and Sham, Sham takes 1 day to make a PPT and I take 2 days to make a PPT. But when working together we will take 2/3 of the day, which is lesser than what Sham take individually, because I am getting my contribution also getting added. So Sham's time will be reduced compared to what Sham used to do alone. So that's what I'm saying. So together, if someone works together as a team, obviously the output will be more or the work can be done faster. That's the basic unitary method of solving. So why unitary? Because from 2 days we are trying to get everyone's work capacity in 1 day, and from 1 day we are trying to see how much time it will going to take. So that's the unitary method. In this, let's say another problem, there is a person A who take 10 days to finish a work, and there is a person B who takes 20 days to finish the same work. Now they might ask, okay, A plus B is going to take how much time to finish the same work. Now if you see carefully, unitary method will tell, okay, A take 10 days to finish a work, so A in 1 day can do 1/10. Similarly B in 1 day can do 1/20. So A plus B in 1 day can do how much? 1/10 plus 1/20 or 3/20. So A plus B can do 3/20 work in 1 day. So one work can be done in 20/3 days. So that's the unitary method of solving, like we did in the previous problem. Now there is also another type which calls the LCM method, which is a notch faster or easier to solve when you have a different days or a little complex numbers to calculate as part of the fraction. So if you have, let's say, A takes 13 days and B take 27 days, so obviously it's a little complex fraction to calculate. So then comes the LCM method. LCM method says consider the total work as the LCM of time taken. So here the time is 10 and 20. So my total work, let's consider, is LCM of 10 and 20. So let's say this is 20. So total work is 20. Now you can think of 20 PPTs they are making together, or you can think of 20 books they are reading together. So A basically I'm saying A in 10 days can do, let's say they are reading the books. So A in 10 days can read 20 books. Basically the total work is of 20 unit. So A in 1 day can read 2 books. Similarly B in 20 days can read 20 books. So B in 1 day can read 1 books. So you know now A plus B in 1 day can read 2 plus 1 3 books. If they read 3 books in 1 day, they will take 20 by 3 days to finish 20 books. So that's a little easier approach compared to the unitary method. So then there are these two different type of ways you can solve most of the time and work problem. But going forward, whatever suits you best, both will give you the answer. So depends on the number given in the problem or what you are comfortable with, you can choose any of the methods. With this, let's move on to the scenario. So what we'll do is there are typically 5 to 6 scenarios. Those are there. We'll try to solve them one by one. So let's say first is scenario 1. Scenario 1, what they're saying is, let's say A take 10 days to finish a work, B take 20 days to finish a work, and then C take 30 days to finish a work. And they're saying, can you tell me how much time A plus B plus C going to take together? Similar to the previous problem, instead of 2%, there are 3%. So again, how we'll start? We'll start with the LCM of 10, 20, 30. And we are saying the total work is 60 unit, or let's say they are reading 60 books. So A in 10 day can do 60. So in 1 day can do 6. Similarly, B in 20 days can do 60. So in 1 day we do 3. C in 30 days can do 60. So 1 day pe C can do 2. So A plus B plus C together in 1 day, they can do 6 plus 3 plus 2 or 11 unit of work. So total work is 60 unit. So 60 unit can be done in 60 by 11 days. So that's how you are going to calculate this. So first we will do the same way, doing the LCM and find the total unit of work. Instead of 1, we'll get the total unit of work as the LCM of the numbers of the times given, and then from there we are trying to figure out what will be the total time they need. Now let's tweak a problem a little more, and let's say go to scenario 2. Scenario 2 talks about A take 10 days to finish a work, and B take 20 days to finish the same work. Same assumption, but A left after 2 days of starting the work. You see, what is the total time you need to finish the work? So A left after 2 days of starting the work. So obviously now you don't know how much is the total time. So obviously you can't start from there. What you definitively know, and that's very important concept or very important things to remember when it comes to time and work problem, is always start from the point which you definitively know. So here we know A left after 2 days of starting. That means A and B for the first 2 days they have worked together. So that's my starting point. So we'll start with the LCM of 10 and 20, which is 20. Let's say 20 unit of work is there. So A in 10 day can do 20 unit. So in 1 day can do 2 unit. Similarly, B in 20 day can do 20 unit. B in 1 day can do 1 unit. So A plus B in 1 day can do 2 plus 1 equal to 3 unit. So in the first 2 days they are working together, they can finish off 6 unit of work. So at the time when A left, there are 6 unit of work is already done. So left is how much? 20 minus 6, 14 unit. Now if I see the 14 unit of work, now for this this is the work B alone has to do. So B in 1 day can do 1 unit, so B will take 14 days to finish 14 unit. So total time will be 14 plus 2, 16 days. But be careful on this, because sometimes they will ask how much time more B will take after A left, or they will say how much time B will take from the point that A has left. So basically, whether you need to find out the time for which B has to work alone to finish the work, then in that case your answer is 14. If they say the total time, like in this case, your answer should be 14 plus 2, 16. So be a little cautious what is asked in the problem. But having said that, in this type of problem, always start with what you know definitively. And in this case, what we know definitively is A and B worked for 2 days to start, and then A left, and we have to figure out how much work has been done in first 2 days when they work together from what we know, and then how much work is left, and that left job, how much time B will take to finish. Simple. Let's move to the next scenario, which is scenario 3, which talks about again same A 10 day, B 20 days to finish our work. Now here we are saying A left before 2 days of finishing the work. So they have not said how much time the work will take to finish, but they said whatever time it takes. A left 2 days before the day the work is finished. So let's say the work take 10 days, A will leave on the 8th day, but you don't know what is the time, total time. They just said 2 days before the work finish, A has left. So now they ask you find out the total time. So in this case also, what we definitively know here, we definitively know that for the last 2 days B has worked alone. Previously what we know, A and B work for first 2 days. What we know now is the last 2 days B has worked alone. So again we'll start with LCM of 10 20, which is 20. Then we know A 10 days pay can do 20, so A in 1 day can do 2. Similarly B 10 days pay, B can do 20 days, so B in 1 day can do 1 unit. So all similar, but so B in 2 days, the last 2 days that B has worked alone, B can do at max 2 unit, not at max, total 2 unit. So in this case, so I know before leaving A plus B has worked together, so A plus B must have finished 20 minus 2, 18 unit of work. Then only the 2 unit of work will be left over, which will take 2 days for B to finish. So 18 unit. Now with this I know A plus B working together in 1 day can do 2 plus 1, 3 unit. So for 18 unit they will take 6 days. So the total time will be 6 plus 2, 8 days. So here what we will start with is, we know definitively B will take 2 days to work alone to finish the work. So B in those 2 days can do 2 unit. So the rest 18 unit should be done by A and B together, and to finish 18 unit of work they need 6 days. So the total is 8 days. So always start from what is definitively known, and from there you calculate further. Then moving to the next scenario, let's do a little complex. Let's make this scenario a little complex. So here we say A take 10 days, B take 20 days, but they are not good friends. For this problem, you think they're not good friends. They say if A is working, I will. B is saying if A is working, I will not work on that day. A is saying if B is working, I will not work on the day. So A and B, instead of working every day together, they work on alternate days. So how much time? Remember one thing, you can't solve this problem if you don't know who starts the work. Why? I will tell you. But let's say A starts the work. So day 1 A will work and we all know previous problem say that A in one day can do 2 unit. So day 1 A will do 2 unit, day 2 B will work, so B will do 1 unit. So together in a pack of 2 day, which is day 1 and day 2, the total work will be done is 3 unit, and I know the total work is 20 unit, same LCM of 10 and 20. So in a pack of 2 days the work will be done is 3 units. So instead of taking 1 day at a time, or we are saying a pack of 2 days, which will make sure the 3 unit of work is done. So similarly day 3 A will work and work for 2 unit, day 4 B will work and again work for 1 unit. So in a pack of 2 days of day 3 and day 4, again 3 unit of work will be done. So let's see what is the closest multiple of 20 for 3 but less than 20. So let's say 3 into 6, or let's say 18 unit. So to finish 18 unit of the work, we need 6 pack of 2 days. So day 1 day 2, day 3 day 4, day 5 day 6, 7 8 9 10 11 12, so 12 days. So there are 6 pack of 2 days. In each pack of 2 days 3 unit of work is getting done. So in 12 day 18 unit will get done. What will happen in day 13? A will work, because A is working on the odd number of days, 1 3 5 7. So day 13 A will work, and A will do 2 unit and make sure the total unit of work is done. So day 13 is the day when your work is finished. So you need 13 days. Let's take it other way. Let's say B does the work, B starts the work. So day 1 B 1 unit, day 2 A 2 unit. So now also in a pack of 2 day, we know 3 unit of work is getting done. Similarly, if I multiply 6 on the both side, in a pack of 12 day 18 unit of work will get done, similar to the past. But what changes is on day 13, instead of A, now B will work. B can do only 1 unit, so total is 19 unit. So the job is not yet done. So day 14 A has to come. A can do 2 unit in 1 day, so A need half day to finish 1 unit. So your total time is 13.5 days. So it's not 13 unit compared to when A was starting, it's 13.5 when B is starting. So if it is in a data sufficiency kind of problem, you don't know who starts the work, you will not be able to answer this problem. So be a little careful when people works on alternate days. It's very important to know who starts the work, right? Okay, moving on. Let's say scenario 5. Scenario 5 talks about, let's do a little complex one. So let's say A and B together take 10 days to finish a work. Similarly, B plus C together take 20 days to finish a work, and C plus A together take 30 days to finish a work. So how much time A plus B plus C will take, and how much time C alone will take to finish the work? So instead of what we were doing previously, we know individually A takes how much, B takes how much, C takes how much. Here we are saying A and B together takes 10 days, B and C together take 20 days, C and A together take 30 days. And then how much time all of them together will take, or C alone will take. Again, let's see, the approach remains same, 10 20 30 LCM 60. So total work is 60 unit. So A plus B in 10 day can do 60 unit. So in 1 day they will do 6 unit. Similarly, B plus C in 1 day can do 60 by 20 3 unit. C plus A in 1 day can do 60 by 30 or 2 unit. So if I add all these 3, it's 2 times of A plus B plus C in 1 day can do 6 plus 3 plus 2 11 unit. So A plus B plus C in 1 day can do 11 by 2 unit. So if you know they take 11 by 2 unit to finish in a day, so for 60 unit they will take 60 into 2 by 11 day. Easy. So that's how you should do. You know, a plus b plus c together will do in one day 11 by 2 unit, so 60 unit will take how much? So basically you add all of them, you get twice of the capacity of a plus b plus c for one day, and then you divide by 2. The other part of the problem which talks about c's work, so we know a plus b plus c in one day can do 11 by 2 unit. If we go back, we see b plus c in one day can do 3 unit. So b plus c in one day can do 3 unit. Oh sorry, we don't need b plus c, we need a plus b because we need to find c. So if we see a plus b in one day can do 6 unit. So we don't need this, so we need a plus b in one day can do 6 unit. So if we subtract now, so it will left with c. C in one day can do 11 by 2 minus 6. Yes. A minute. So a plus b. So it's negative. Just give me a minute. So 11 in one day. B plus, just let me see if things are correct. A plus b plus c 60 units, so a plus b in one day can do 6 unit, b plus c in one day can do 3 unit, and c plus a in one day can do 2 units. So together in one day they do 11 unit, and in half day. So I think there is some problem with the values. So I see, so that is coming as minus half. So obviously here what we are actually figuring out is that c plus 8, the values we took, and I just took randomly, so the values we took actually making sure c is negatively contributing to the work. So c is delaying the work, c is not positively contributing, so c cannot finish the work. So always if the problems are given, again a very good point for a data sufficiency kind of problem. If you just see that all these individual values are given and you think that you will be able to find out c, how much time c will take to finish the work, it may come up that c is coming as negative, so c will never finish the work. I'll talk in detail how the delaying or the negative kind of work works in the next scenario, but in this case what we see, c in one day actually doing a negative work. So that's why you see a plus b take 10 days but c plus a take 30 days. Probably c is delaying the work. How it impacts we'll talk in depth in the next scenario, but here we know c cannot finish the work because c is contributing negatively. So if we have to do this, let's say I'll talk about how much time a will take individually. So a plus b plus c in one day can do 11 by 2 unit. So b plus c in one day finish 3 unit. So if I subtract, so I know a in one day can do 11 by 2 minus 3 or 5 by 2 unit. So a can do 5 by 2 unit in one day, hence 60 unit can be done into 60 into 2 by 5 or 24 days. So a can finish the work alone in 24 days. So obviously with c we will not be able to figure out, and c is coming out as negative. So how the negative work happens, but before that hope this part is clear. From two person working together, if this kind of scenario is given, and how you can find out how much time each one of them alone will take. Now coming to the next scenario, or scenario 6, is basically negatively contributing. So let's say a is finishing the work in 10 days and b destroying, or b not finishing. So till now what we were doing is A is contributing positively, B is also contributing positively to the work. So A take 10 days to finish, and let's say B take 20 days to destroy. So basically B is basically delaying, or B is basically destroying the work. Similarly, what we got, C is negative. So C is negatively impacting the work, here B is negatively impacting the work. So now one important thing here is to remember is capacity, or we'll talk about efficiency. So what is the efficiency means? So efficiency means A take 10 days to finish a work and B take 20 days to finish another work. Let's say B is now, for a moment think B is not destroying, B is also contributing positively. If A take 10 days to finish a work and B take 20 days to finish a work, A is more efficient than B. Now think this case, if A take 10 days to finish and B take 20 days to destroy, A is still more efficient than B. If A is not more efficient than B, then the work will never get finished. Similarly, if B is more efficient than A, then whatever A makes, B will destroy. So the work will never get finished. So here efficiency wise A is more than B. So similarly we'll start with LCM. Let's say together they said how much time it will take. So LCM of 10 and 20, again 20, A in one day can finish 2 units, B in one day can destroy minus 1 unit. So B in one day contribute 1 unit or destroy minus 1 unit. So basically we can say A plus B together 2 minus 1, 1 unit in one day. So similarly 20 unit will be done in 20 days, right? So that's how the negative contribution works. So instead of adding, you just have to subtract the person who is destroying the work. The same concept of one person positively contribute, other person negatively contributes, works the same way of a pipes. These are kind of applications you can think. So one of the main application of time and work is the pipe and cistern. So there is a cistern, there is an inlet pipe which is filling the tank, and then there is a outlet pipe which is take the water out of the tank. Now what you need to know is efficiency wise, inlet pipe efficiency has to be more than the outlet pipe's efficiency if you have to fill the tank, or outlet pipe efficiency has to be more if you have to empty the tank. So the other way, so let's say there is a let's say a tank which is of 20 liter capacity. Then there is a inlet pipe which, let's say, can fill the tank in 4 hours. Then there is a outlet pipe which empty the tank in 5 hours. So what do I mean by the inlet pipe taking 4 hours to finish? So it can fill the empty tank in 4 hours. This means empty a filled tank in 5 hours. So the outlet pipe has a capacity of 5. Outlet pipe takes 5 hours to empty a filled tank. Inlet pipe takes 4 hours to fill an empty tank. So that's the capacity of an inlet and the outlet pipe. So again, what we'll do, we'll start with LCM of 4 and 5, or here you know it's already given 20 liter. So inlet pipe in 1 hour can fill 5 liter, because 4 hours if you fill 20 liter, in 1 hour you have to fill 5 liter. Similarly, outlet pipe in 1 hour can take out 4 liter. So together inlet plus outlet in 1 hour can fill only 1 liter, because inlet pipe is putting 5 liter water, outlet pipe is taking out 4 liter of water. So at the end of 1 hour there will be 1 liter. So the 20 liter will take 20 hours to completely fill. So that's what it talks about, the inlet and outlet pipe. And this is the another type of application of time and work, where we talk about inlet outlet pipe. So I think mostly these are the scenarios that you need to aware of in case of a time and work kind of a problem. Just let me have a look if there are any other scenarios, but I don't think there are any other scenario you need to understand in case of a time and work problem. Just a minute. So yeah, so if you understand this 5 to 6 scenarios correctly, if you solve few problems about pipe and cisterns or tank and pipe, I think most of the time, 99% time and work problem will be done. Rest, there will be certain variations. We will try those edge case problems which does not come any particular concept, but extension of these concepts when we solve the problems. So this session was primarily on time and work basics and fundamentals needs to be cleared. The next session, again like I mentioned, will be on the level 1 problems, which will establish these fundamentals that we know, and then we take off on the third session of time and work, where we do advanced level of problems from time and work. So that's how we will cover each topic. So we started from time and work, and slowly we move on the other topics. In case of you have any doubt, you want me to help you on one-on-one basis, you can possibly reach out to the email ID that I will drop in the description box, and you possibly reach out to me and we will take it from there. So with this we can stop. Hope you have a nice session and have a nice day, and reach out if you have any doubt on this. Thank you.